Good morning. I'm Riley Burgundy, and here's what's going on in your world this morning. Today, there has been a mysterious development in Paducah, where local residents have reported that a barrage of projectiles have been raining down from above. So far, the National Weather Service, NASA, and Homeland Security have been baffled by this unexplained phenomenon. President-elect Donald Trump has commented that this is huge, but the Russians are not involved.
And if it is Russia, which is probably not, nobody knows who it is, but if it is Russia, it's really bad for a different reason.
We have our entire newsroom team working to bring you the facts of this story. We will now go to the scene with our reporter on the ground, Sean Shalola, who has put himself in harm's way to bring you this report. Sean, are you in danger right now?
Thank you, Riley. We're here at the WKCTC, where there has been a downpour of brimstone, or what should I call it, projectiles from the sky. And it's more or less as if it's a rain of fire in this campus. As you can see behind me, the school is empty and every student and instructor has fled for safety. We don't know the cause of this projectile, neither do we know the source, but we believe that our specialists can work on the tracker application, which can describe projectiles, their source, the velocity, and the motion to find where it is originating from. We are going to see what our specialists can do, and then we're going to give you more reports. At this point, oh my God, what is that? Oh my God. That was a very close one. I think we're gonna leave this place right now. For the meantime, I'll be back to you, Riley.
Now let's turn our attention to local meteorologist Dallas McKinney in our weather center, who has been using Doppler Radar and tracker to bring us the most up-to-date information available. Dallas, what can you tell us?
Riley, the situation here is tense. We've been using our Doppler radar as well as our tracker system to analyze the trajectory of these incoming objects. Using our tracker system, we've been able to analyze the arc as well as the velocity of these dangerous objects. And we're actively working to find out what the origin of these objects are. Here's the breakdown.
In this tracker video, that the projectile, there we go, its motion can be described at first by the conservation of energy, which begins with the equation UI plus KI equals UF plus KF. Now in this scenario, the K initial, or kinetic energy initial, is 0. Since it begins from rest. As you can see in this position, the counterweight's up high right here and begins at rest, and it has totally potential energy. But then after it begins to launch, it transfers the energy from potential energy to kinetic energy. And at the end of this, there's no more potential energy, it's all transferred into kinetic energy. At about this point, it's already reached the bottom of its swing, and so there's therefore no potential energy. Now, as describing how this energy is transferred and the proportion of it, the energy is spread between the counterweight and the projectile ball. And since the counterweight has a higher mass, then it has most of the energy associated with the system. But the smaller projectile also gains a large amount of energy compared to how massive it is, and therefore gets launched farther. So that's the launch, the physics during the launch. But then you go to the physics in the projectile motion. And that's described by the equations x final equals v cosine theta, which we determine theta by looking at these and the proportion between these points. And we found that it was launched about an angle of 49 degrees. And so you can plug that in and you can see that it follows the projectile arc here. It goes in an arc just like you'd expect with a normal projectile until it lands at this position. And that can be described by y final equals y initial plus v sine theta t minus 1/2 gt squared. And those can be solved for each other to solve for t, and you can come up with the final point there. Alright, and that's projectile motion. Now, using a projectile motion, we can determine what the force of impact on the ground by the ball is at the moment of impact, and the force is described by the equation square root of mgh max squared plus v sine theta m squared. And you can see here the ball we used did not bounce very high, so most of its energy was transferred to the ground. So this is the breakdown of the physics. If you know the final position, then you can go back and approximately determine where the initial position was. The equations are solvable like that. And so if you do that, we found that they're coming from an interesting direction. And we'll go back to our other shot to show you exactly where they're coming from.
So if we plug it in to our Doppler Radar, our Sky Tracker Doppler Radar, brought to you by the local trash company. And so if we do that, we can zoom in, and it looks like it's zooming in the WKCTC campus. And if we zoom in further, it looks like it's zooming in on the UK Engineering Building. Riley, this is astonishing. Back to you.
Thank you, Dallas. Ladies and gentlemen, this story is unfolding right before your eyes. Our investigative journalist Robert Mole is on the scene at WKCTC campus and has been interviewing eyewitnesses. Robert, what have you been able to find out?
Riley, I have with me a UK engineering student, Sarah King, to shed some light on this perplexing situation. Sarah, would you tell us a little bit about this projectile?
This is not a weather phenomenon or the work of the Russians or Putin. Ew. As some had theorized, my physics instructor, Dr. Tavares, is very responsible.
Riley, this is stunning accusations and will have to be verified. I understand that our roving reporter, Sean Chalola, is on his way to Dr. Tavares' office as we speak.
Let's now go to Sean in front of Dr. Tavares' office.
We're here at Tavares' office and we're trying to ask him some few questions as regards what is happening right here on campus. We've tried getting into his office, but right now his door is locked and we need to talk to him to see what he knows about the projectiles happening on campus. Oh, we just got to know from an external source that Tavares is actually in his 9:30 to 10:45 a.m. class teaching them physics right now. We'll try to get a hold of him and see what he knows about all these projectiles. Thank you. Back to you, Riley.
I'm receiving a report that Robert has found another eyewitness that says he's worked with Dr. Tavares. Robert?
I have with me John C. Higgins, a man who has created these launchers. And John, will you please tell us a little bit about this design?
Of course. So we have here a model of what we believe to be the instigation of all this trouble. Appears to be an annual event, as far as we can tell, caused by launchers similar to these. These projectile launchers are highly dangerous. If you see one, do not approach it. Highly dangerous. The method, of course, for this one that you can see, the example we have with us today, is powered by potential energy of a mass on one end. That's going to cause a moment across an axis, which will then propel the other end by an equal moment. But the important thing to remember is that this is strictly an annual event. This is strictly an annual event. There will be a summation as the series approaches the end of the semester that will cause this activity to cease. There is no harm to the public beyond the present time. So that's the main development here. That's mainly what you need to know about, as well as the operation. Know how to keep yourself safe. That's the most important part, Robert. Know how to keep yourself safe.
Well, thank you, John.
Of course.
Back to you, Riley.
Great story, compelling and rich. One thing's for sure, we can all rest assured that we are not under attack, that this is just a physics experiment. As always, you stay classy, Paducah. I'm Riley Burgundy.
Who typed a question mark on the teleprompter? For the last time, anything you put on that prompter, Burgundy will read.